morning, everyone. So for this year, this is our last talk, and really important one because we're going to talk about disease trilogy, which is impacting our metabolic health and leads to metabolic syndrome, right? So we're going to talk the interconnection between type 2 diabetes, chronic kidney disease, and cardiovascular disease, which has been missed by almost 99.9% of the healthcare practitioners, right? And we're going to understand the deep-rooted connection between with oral macrobiome as well as gut microbiome, right? So, let me probably hand over to Sakshi, and Sakshi could give a brief of what we are going to discuss, and then we can just hop on to questions.
So, good morning, everyone. Today, this video is for all those people who, in their families, have experienced the onset of chronic kidney diseases or type 2 diabetes or cardiovascular disease. So, what today we are discussing is that how these diseases are connected to each other, first thing, and second, how they occur in the first place, and why our current healthcare system has missed the interrelation between all these three diseases. So I hope, Sushant, let us first begin with a very this disease which has affected millions of people, and it ends at dialysis. So let us first talk about chronic kidney diseases, how it occurs, and why there is no other solution for this disease.
First basic flaw in understanding these diseases, every doctor, healthcare practitioner treat every disease differently, every organ differently, which is a wrong way because everything is connected. I'm going to tell you how. So, when you talk of chronic kidney disease, there are three basic way we develop this disease, right? And again, two of the ways are connected with production of nitric oxide, right? And again, for those who have not listened to my previous talk, right, nitric oxide is one of the most essential gas which is produced inside our body every 3 seconds, and it wipes off every 3 seconds, right? So essentially, it is one of those essential molecules, gas, which regulates a lot of functions. It regulates your blood flow. It it is a vasodilator. It helps you improve your blood pressure, and a lot of these functions. So let us discuss about nitric oxide. So nitric oxide again is produced through two different pathways. One is what we call is endothelial cell E nitric oxide synthase, which is an enzyme, right? So again, we'll start with understanding with the type 2 diabetes and how it impacts chronic kidney disease, right? So, and here is the role of the microbes living in our mouth, right? So whenever we come across, we eat something sweet, these microbes in our mouth pre-digest the food and send the signals to pancreas that something sweet is coming and please start releasing insulin, right? So pancreas releases insulin. It actually binds to insulin receptors on most of the cells, but basically fat cells, muscle cells, and liver cells, right? And there is a cascade of molecular signaling, insulin signaling, chemical signaling happening, which all diverge at or converge at ENOS nitric oxidase, right? So if your body is producing enough nitric oxide, probably if there's no oxidative stress. Again, I'm just a bit of kind of why you may have nitric oxide deficiency. Again, it is linked to your chronic kidney disease. So a lot of this is produced by L-arginine. L-arginine is an semi-essential amino acid. So it doesn't mean you have to take too much of L-arginine, right? Your body itself produces L-arginine through urea cycle, right? And L-arginine is one of those molecules which is used to produce nitric oxide, right? And there is so there can be a lot of ways in which nitric oxide production uh, deficient. One is obviously oxidative stress inflammation, right? And these all are caused by gut microbiome. So if your gut microbiome is producing a lot of TMAO, which is again byproduct of choline, or LPS, which is again an endotoxin, or producing less of short chain fatty acid. There's a huge inflammation going on, which or oxidative stress going on, which suppresses your nitric oxide production. Other is obviously the decrease in transport of L-arginine to endothelial cells. Again, endothelial cell is, to understand, it as a cell lining our blood vessels, right? And it is the most important cell inside our body, right? Again, another thing is what we call is asymmetric dimethyl-arginine. It is again a nitric oxide inhibitor, right? Which is again a byproduct of L-arginine, produces chemical produced inside the body. If there's a lot of increase of this, or there's oxidative stress, there's inflammation, or reduced transport of arginine to endothelial cell, right? These all impact to nitric oxide deficiency. Again, another important thing is, there is a enzymatic cofactor called, tetrahydrobiopterin, right? And again, this is an cofactor for ENOS, nitric oxide synthase. And if this is uncoupled or if it is not produced, a lot of this L-arginine, even if your endothelial cells are getting L-arginine. If this cofactor is not there, your ENOS would produce oxidative stress instead of nitric oxide, right? And this oxidative stress causes cardiovascular disease, right? This is one way. So coming back to the question of nitric oxide deficiency, if there's a nitric oxide deficiency, right? So it it does not produce or probably, let's put it way, if there's enough nitric oxide production, right? None of this inflammation is happening, ADMA is not there. There's a proper flow of L-arginine, or there's a proper coupling of this tetrahydrobiopterin is there. There's no oxidation of this. So essentially what happens is that, your the GLUT4, which is the protein, is released, right? It goes to the cell, basically cell membrane. It binds the glucose, which is there, right? And it brings back, remove the glucose from the circulation, bring back into the cell, and that's how you clear the glucose from your circulatory system, and you get energy to your cells, right? And again, so here is a very important role of nitric oxide in regulating your insulin responses, right? But if your nitric oxide is deficient, if GLUT4 is not produced because of this deficiency, right? So there's a lot of high level of circulatory level of sugar, and again the message goes to pancreas to release insulin to do this act again, and over a period of time, this becomes insulin resistant, and probably you will have high blood sugar levels, right? So when you have high blood sugar levels, right, it sometimes and it becomes chronic. It actually damages your blood vessels in your kidney, and you start having chronic kidney disease, right? It's so I've shown the interaction, the connection between type 2 diabetes and chronic kidney disease. Unfortunately, over last few years, if you see 5, 7 years back, there was no technology in place to measure nitric oxide. Again, that is one way. Other way, here comes the role of again oral microbiome, because a lot of these microbes in our mouth convert nitrate in various green vegetables into nitrite. And if you have enough stomach acid, this nitrate mixes with stomach acid to produce nitric oxide, right? So again, over a period of time, this endothelial cell way of producing nitric oxide starts reducing as we age every year by 5 to 10 years. So when by the time we reach the age of 50, right? Production of nitric oxide is reduced by 50%. So that's why the role of oral microbiome becomes all the more important, right? So that is something which has been missed. So nobody talks about the microbes and how the microbes in the mouth can cause chronic kidney disease, right? Nitric oxide deficiency or type 2 diabetes, right? So that's one connection. Obviously, if someone is already on cholesterol lowering medications, right, or protein pump inhibitors, right, so obviously this will also interfere with nitric oxide production. This can actually counterintuitive. This can cause type 2 diabetes, can cause chronic kidney disease, and even increase your blood pressure, right? So that is one way you look at it. Other way is obviously when you have this oxidative stress, right? It causes cardiovascular disease through oxidative stress, and and so this is one uh, pathway through oral microbiome through nitric oxide deficiency, which causes type 2 diabetes, high blood sugar level, which damages the blood vessels in kidneys, causing chronic kidney disease. Other way, if the nitric oxide production is not there because of because of a lot of decreased production of arginine, or this cofactor is not there, the tetrahydrobiopterin. So probably this can make nitric oxide produce reactive oxide species instead of nitric oxide, right? So that oxidation leads to cardiovascular disease, right? And another important thing is if you are thinking, you're taking, oh, I have low NO production, right? And let me take some lot of L-arginine. Again, what happens is when you consume a lot of L-arginine, it increases the expression of another enzyme called arginase, and arginase and ENS compete for L-arginine, and probably it leads to more of ammonia production, which further impacts your kidney functioning, right? So there is a deep-rooted connection between your type 2 diabetes, cardiovascular disease, and chronic kidney disease from oral microbiome perspective. So when you're talking about dialysis, so these all things are never decoded by doctors, right? And ultimately you never see the connection between type 2 diabetes and cardiovascular disease, and you just end up dialysis. That is one angle. So if you have any questions on this, probably you can answer them.
So,
Whatever that is.
I have a question here. So, when we are talking about dialysis, so dialysis is about blood purification. Yeah, they purify the blood. So, and it's like a mechanism because the purification of the kidneys, it stops. It either gets damaged or it stops. So it's like a support system, right?
Mm,
Because the traditional medicine and the traditional studies, they tell us, okay,
mm,
this is the functional role of kidney, and when it stops
mm,
performing that certain function, a person is recommended for dialysis. And I mean,
mm,
and we have also seen that people who are not really having a damaged kidneys or a glomerulus, then also they are recommended dialysis, right? So I think, is it about the diagnosis or is it about the correlation versus
okay.
causation?
Okay, so what we discussed right now was one aspect of how we develop chronic kidney disease, which is via nitric oxide, L-arginine. So if there's a lot of L-arginine, as I mentioned, arginides can produce ammonia. Ammonia can impact kidney function. That's how you develop, chronic kidney disease, right? So obviously, your elevated blood sugar level, your high consumption of L-arginine, impaired uh, biosynthesis, renal biosynthesis of L-arginine, right, or reduced production of L-arginine, or probably L-arginine being metabolized by a lot of arginides, right? Because of excess production, because of increased expression of arginides, right? Or asymmetric dimethylene, right? Arginine, which is again in nitric oxide inhibitor. So these are all things happening at a molecular level, which no doctors understand, no doctors decode, right? There is obviously certain, so you have to see from, that's why I'm going to introduce the concept of gut microbiome now, right? So the way is, if your body is producing a lot of toxins, right? There's a way of kidney to filter it out, right? So that's why the kidney function is to filter out all the toxins, right? So obviously, if you have an oxidative stress, there is TMAO being produced, there is LPS being produced, right? Which is again endotoxin. All these kidney do that function to excrete that, right? Uh, so here comes the role of gut microbiome. Now, a lot of you must have heard that eat less protein for kidneys. There's it causes a lot of toxins, and it is causing a lot of urea production and all that, right? So again, as I mentioned, urea production is because of a lot of L-arginine. We think L-arginine is something which is we should take from the diet. It is a semi-essential amino acid, right? You really don't need to take too much of L-arginine, right? And that's a shame because there's a lot of supplements, even bodybuilders are taking a large amount, right? So to feed. And here comes the role of gut microbiome. So a lot of these, understand this, there's a lot of these things going on around high protein diets, right, without understanding. So there are 20 amino acid, 9 essential and non-essential, right? You don't need to take non-essential from your diet. You need to take 9 essential amino acids from your diet, right? And again, these includes phenylalanine and tyrosine, among others, and tryptophan, right? So here I'm going to talk about two relevant, uh, biomarkers, which is the byproduct of gut microbiome metabolizing a lot of these proteins. So first is obviously the, you know, what we call is peak resolve, right? Which is again a tyrosine. So if you're to consuming a lot of foods which are high in tyrosine, you milk, turkey, a lot of these things, right? So there's certain microbes, if your gut microbiome is imbalanced, they can, or probably you're feeding a lot of these amino acids, they can convert tyrosine into peak resolve, right? And again, Finland can so that is one thing how it gets, and this is an endotoxin, right? This puts pressure on your kidneys over a period of time. If you are too much consuming too much protein, it makes your kidney less efficient, and these peak resolve is becomes the level of peak resolve is high in your circulatory level, right? So there's a lot of high flow of peak resolve in your circulatory level, right? Other thing is tryptophan. Again, tryptophan is a double-edged sword. So depending on what microbes are there which are metabolizing tryptophan, it can either produce serotonin, which can improve your mood and memory, or it can produce indoxyl derivatives. So there is a called indoxyl sulfate. Again, indoxyl sulfate is an endotoxin. It puts pressure on your kidneys and it leads to high circulatory level of yeah. And indoxyl sulfate and pregabalin. These two are all produced at a molecular level, so no doctors decode this. And these are very high circulatory level of these endotoxins in your blood circulatory system, which actually impacts your kidneys. Over a period of time, your kidneys stops become inefficient or stops functioning, and that's why you go on a dialysis to clear all these toxin and endotoxins. But this story doesn't end here, right? So these high security level of these endotoxins create a lot of oxidative stress, which again causes cardiovascular disease and death through heart disease, heart stroke, right? So again, there is a connection, obviously, and the gut microbiome also, we have discussed this earlier, that it has a role to play in type 2 diabetes through various metabolic pathways such as tyramine, low production of nitrate, low production of IPA, indole propionic acid, right? Uh, High level of, fructose metabolism, fructose metabolism. There's multiple pathways what we look at, right? So again, gut microbiome and neural microbiome both have a deep connection between chronic kidney disease, type 2 diabetes, and cardiovascular disease, right? Again, another important biomarker what we have from cardiovascular disease perspective is PAG, phenylacetyl Again, it is a microbial metabolism of a lot of this amino acid called phenylalanine, right? Again, phenylalanine is something found in chicken, in eggs, in milk, in a lot of nuts and seeds, right? And if you have a lot of proteobacteria active, it can actually produce PAG, which causes cardiovascular disease, right? So, chronic kidney disease is connected both with oral and gut microbiome. There is a way where type 2 diabetes ropes in and causes chronic kidney disease, or your dietary choices were consuming a lot of L-arginine, which is making arginine active and producing ammonia and, overactivation of urea cycle, or there are certain endotoxins because of high protein diet, which is precresol, such as precresol and endoxyl sulfate and PAG, which causes chronic kidney disease and cardiovascular disease respectively, because it causes. So to answer your question of dialysis, right? So the blood purification is required because blood has to purify it from this a lot of these endotoxins which are there in the circulatory system, right? And it is because of a lot of these byproduct of protein, and that's a wrong approach that you need for to lose weight, eat a lot of protein, because I've seen people who are getting on a lot of high protein diet, they're going to develop either cancer, chronic kidney disease, cardiovascular disease in maybe 5, 10 years time.
That's pretty sad, but I think it's very important to understand that further, once a person has type 2 diabetes or chronic kidney disease, right? Cardiovascular disease, what I feel, it is the last impact. It happens at a very later stage.
It's yeah, but it can happen independently also. So as I mentioned about cardiovascular disease, like TMAO I mentioned, right? So again, trimethylene oxide, it is a byproduct of microbes eating a lot of choline and L-carnitine, right? So people think it's only non-Asian, so probably things like kidney beans can cause production of TMAO, and TMA goes into your bloodstream, crosses the liver, and converts into TMAO, which is an independent risk factor for cardiovascular disease, even for causing hypertension. Hypertension, when there's a hypertension, it actually stops the production of this tetrahydrobiopterin, again, which causes chronic kidney disease. So it is always connected. So chronic kidney disease can happen via type 2 diabetes, via cardiovascular disease, or independently also, right? Similarly, type 2 diabetes can be caused by nitric oxide production, right? Or gut microbial dysbiosis. Even people think it's consuming high protein is going to prevent type 2 diabetes. There are certain metabolites which is a byproduct of, like for instance, if you're taking a lot of is histamine, right, which leads to production of enzyme propionate, which is again an independent risk factor for type 2 diabetes, which all things happen at a molecular level. So nitric oxide is the most essential molecule which has been made studying, right? So it can happen from either way. So cardiovascular disease can start right because of TMAO, right, or PAG. You can have cardiovascular disease. TMAO can suppress your tetrahydrobiopterin, which can cause nitric oxide deficiency, which can cause type 2 diabetes, which can cause cardiovascular disease, or cardiovascular disease independently can be caused by P-cresol and doxycycline, which can cause cardiovascular disease. Sorry, chronic disease, which can cause oxidative, which can cause cardiovascular disease, right? Again, preglycerol is also suppresses your GLP-1 production, which causes type 2 diabetes also, right? So there is always a connection, right? We don't consider that. We think, okay, if I have chronic kidney disease, probably let me do a dialysis, let me clear this shit going on inside my blood, and probably I'll keep the customer on dialysis for maybe a number of years till the time he's alive, and there's no solution. You'll keep on clearing it, right? There's actually no solution because we have not addressed the root cause. We have not seen that where this toxin is coming from, why it is coming, who is responsible for producing these toxins, which microbes are informed, which microbes active, what genes they are expressing, right? The multiple things that play here. And similarly, type 2 diabetes also, we just focus, okay, if this is very important, right? So from a type 2 diabetes perspective, if you are tracking your HbA1c levels or you using your CGM machines to track your sugar level, it is just waste of time and money. Because if your sugar level is high, it means that your body is not able to clear this glucose from circulation, right? Or there's a nitric oxide deficiency, so there's a lot of oxidative stress, which is actually uh, not making your pancreas produce enough insulin, or they have been a lot of insulin being produced so that pancreas become less efficient, and that's why you don't have this, and you just keep on suppressing blood sugar level. So type 2 diabetes start developing 20 years before you start developing. Similarly for chronic kidney disease, it's not something you develop overnight, right? You start developing around 10 12 years 15 years back, and it's a silent disease. You don't know that, right? Because you these biomarkers are missed, right? So that's it's the body is a self-correcting mechanism. If you keep on putting pressure, it will give up, right? So that's what is the deep-rooted connection between all these three diseases, and which is being missed, right?
So I think we've covered pretty much. Yes. I
Mm.
had another question in mind that I mean it is related to a bit of a mental health. So what we have seen that people with later stages of type 2 diabetes, CKD, and
Mm.
sometimes even cardiovascular disease, they start to have problems like dementia, and even it could go up to Alzheimer's or Parkinson's. There is a chance it develops in the later stage.
That's a big discussion, but I'll just say here that certain microbial metabolites can actually, in case of Alzheimer's, it is also called type 3 diabetes because your brain again is an insulin sensitive organ, right? So there's a lot of these from a neuroinflammation perspective, right? LPS is something, and that's why you'll find people who have elevated blood pressure have mental health issues as well, right? So a lot of this endotoxin, this LPS, can cross the blood-brain barrier, go to brain and start doing inflammation there, right? This is, and again, if your tryptophan is being used to produce endoxin sulfate, not serotonin, which is again and neurotransmitter required for regulatory on mood and memory and a lot of these happiness and a lot of these things. Alzheimer's and dementia and Parkinson's, these are separate discussions which we can have
Yes.
maybe in a separate talk, right? But to just to briefly mention, yeah, because Alzheimer's and type 3 diabetes, brain is an inflammatory organ, so obviously, people who have type 2 diabetes have high risk of developing these neurodegenerative disorders, right? Or probably if your body is producing a lot of endoxin sulfate, it is not producing serotonin, that is can cause depression and mood and a lot of these things and gut role of gut brain axis because gut and brain communicate to each other through the vagus nerve. So whatever you eat have an impact on your mental health as well, right? So the byproduct of what you eat can travel to brain and can do inflammation there, right? And that's what is really important to understand, right, from a brain health perspective as well. So we can have a separate discussion on Alzheimer's and
Yes,
dementia.
yes, of course. I highly recommend we should have a discussion on mental health. So I think with this, we come to the end of this video. And in the end, I would like to say that all those people who think that their family members or, their friends or loved ones, if they're suffering from any such disease, please, it is very important for you to understand that what is the root cause behind. And in order to do that, I think it's very important nowadays to decode the oral and the gut microbiome. Whether it does not matter whether you go for a test or not, but understanding why is it happening is going to make their lives easier, because many things they can be resolved with the help of nutrition. Am I right, Sushant? Here?
Yeah, and important to think if you are going for your blood test for your cardiovascular disease or your chronic kidney disease or your type 2 diabetes, it is not going to tell you anything. It is going to tell you something is imbalanced, right? Now, why it is imbalanced doesn't tell you. So obviously, doctors would adopt an generic way of, okay, let me give you metformin, let me give you this diet, let me put you on dialysis, right? Let me give you statins, right? Again, a lot of these things there's no concrete insights about why you're developing a disease, right? And that's why oral and gut microbiome become really important, right? In oral microbiome specifically, it has not been so I've seen a lot of people studying about gut microbiome. Also, we also started with gut microbiome 4 years back, right? But oral microbiome is as important, if not more, than as gut microbiome, right? So we are the only one in Asia actually understanding or decoding and measuring the functions of your oral microbiome, right? So we can tell you what is nitric oxide production, what is your urease pathways, right? Why you have bad breath, whether you have a risk of halitosis, the risk of type 2 diabetes, the risk of chronic kidney disease, arthritis, a lot of these things, right? Understanding these is key. It is not something, these are not quick fix things. These are real lifestyle disorders, right? Which needs to be addressed, right? And it has to be, you have to understand your biology at a molecular level, what is going on, how your genes are being expressed, how your cells are interacting, what molecules are being secreted, right? Why you have food intolerance, what metabolites are secreted by microbiome, what cytokines are being upregulated, right? Uh, how you can transit from unhealthy to healthy state, right? So you may have a lot of these apps which may say you can track your menstruation cycle, track your blood sugar level, track your heart health. Another thing which is coming is, so I'll probably that will have a different discussion on heart disease specifically with respect to LDL and HDL, right? But just mentioned that a lot of these now people are saying, measure your APOB. Again, APOB is nothing but a protein which is a preloprotein B, right? B100, which is again is overexpression of this protein is said to increase your what do you call as LDL or reduce to less clearance of LDL, right? And again, this is so you don't know why you have, so you don't understand. Okay, I have a APOB high, but why, right? Even if you track APOB high, right? Does it tell it? So what do you need to do, right? There's a multiple factors at play. You will start eating less carb, you will start eating less fat, right? What you eat, right? So that again, APOB is again overexpression is because of a lot of these. Again, I mentioned about TMAO, I mentioned about bile acid, altered bile acid metabolism, a low short chain fatty. So there are multiple things, right? So we can have a separate discussion on LDL and HDL, right? Just to tell everyone that there's nothing called as good or bad cholesterol. It's all created by doctors, right? To make you believe that you actually start suppressing your cholesterol, start taking cholesterol lowering medications. Yeah.
So with this, we end this video and let us in our next video. Sushant, what are we going to talk about?
So with next year, probably next year, we'll discuss about LDL and HDL, right?
Okay.
In detail.
Okay.
Yeah.
Yes.
Yeah.
Yes. Thank you. Thank you so much for viewing this video. Have a great day ahead.
Thank you.